to start right with Docker first, we need to understand what we call this virtualization. So my first question to everyone, right? For you, what is virtualization? So what is your definition of virtualization? Anyone?
Imagination.
Yeah, virtualization.
So
Yeah.
the the virtualization feature allows us to like the physical machine divided into uh, multiple virtual machines is called an virtualization.
Okay, so now you were talking right specific to certain. So in a generic, right, it is something right replicating something right as a whole. If you see right, for example, if you come in front of mirror, right, that is also a virtualization. True or not? Yes or not? Right? In a way, right, you can see right a virtual image of yourself. So virtualization can be divided into many parts, right? It's not about only right. There is right OS virtualization. There can be right memory which can be virtualized, right? Disks can be virtualized. So obviously, this virtualization right had helped a lot, right, in terms of right basically resource optimization, right? In terms of that, right, it has been very much right in use, and you will see right we do in some or other case we use this right virtualization. Now, in context of Docker, yes, we have to understand right what is OS virtualization, and yes, you rightly say right. Uh, I can buy a very good hardware, right, or you can say machine, right, which is a server class machine, and I started using it right for my application. So, say diagrammatically, if I explain you that, drag it, it's not getting dragged. Just a minute. Mhm. Problem. Yeah. Hmm. So I'm talking in terms, right? I bought a very good server class machine and started running my right workloads over it. Since it has right a good amount of memory, disk, right, and it's a very right resourceful right machine that I have buy it. So I thought of right launching some application over it. Even my database is in it, right? Now, problem in such case is what, right? So obviously, when I'm doing application development and I'm creating multiple right modules working in same instance and right interacting with each other, so I am actually using a monolithic architecture, right? So that's what I'm currently explaining. So let's take this example. This is very good hardware, right? And over that, I obviously right installed an operating system. I will use something else for it maybe later. This triangle would be better. Now this is a machine right with a good amount of RAM, right, CPU, disk, right, uh, and I actually right installed an operating system or placed an operating system over it, okay, and which is working right fine, right, and in this basically I installed certain applications. So I have say application A running here. I have app B right running here, and I have a one database also, right? Because it has good amount of RAM, CPU, disk, so I can right have all this right installed in a single operating system. And remember, this all applications, right, which are different application databases, are using what? Are using basically OS library, right, which gets right installed when you install what your operating system. So obviously there is an OS library that they are using. Now, problem in this situation, which is a monolithic architecture, which generally was used earlier, right? When we do not have right virtualization so popular, and right, we tend to right fall into the practices, right, like this also. So there are few things. For example, I have application A which consumes around say 8 GB of RAM, and FB which contains it's a 4 GB of RAM, and DB right takes around say 15 GB of RAM, and I have right good amount of 120 right 8 GB RAM, and I have around right 20 or 30 CPUs, right, and disk is also right too much. So obviously I am able to use that, but at the end if you see I'm not utilizing the resource completely. Still I have certain RAM, CPU, right, and disk, right, which is underutilized. True or not? Hello.
Yes.
Either I will do what I will try to right install multiple application or module right in this, but there is some challenge. Now challenge in that term is of what? For example, the app A, which is running here, right? I want to optimize it because I see right certain surge in business, and app A needs a lot of interaction with say customer, right? Maybe the API is related to it, or maybe right whatever the calls right that it handles is increasing. And when I try to optimize, I need to tweak certain right OS library, right, which is related to this particular operating system which I have installed over the hardware. If I tweak some right configuration of the OS library, we can see or we can assume right it might impact right either DB or AppB, right. So we have to be very careful. Making changes or optimizing one module right might affect right other module or applications because they are all right interacting with the same library right or OS. So obviously OS optimization right for an application becomes difficult to do in this case because this app A, app B are running on the same operating system. It makes sense also, right? It may happen, right? Yes or no?
Yes.
Yes.
Now to solve this problem, what we can do then, right? Yes, virtualization, right, came in picture. Now, virtualization can be achieved how? Can anyone tell me how I can achieve right virtualization? Are you aware of any technology, right, which right helps right in having virtualization enabled in right a hardware? Have you heard about hypervisor?
Yes.
So, yes. So obviously we need what
Hypervisor.
hypervisor to right achieve that. Now how basically right this is achieved? Let me tell you. First of all, our hardware, right? We need right something called hypervisor. So hypervisor are of two types: type A, type B, right? So the first type, right, is a hardware-based hypervisor. Another type is what? A software-based hypervisor. So when I talk about hardware-based hypervisor, obviously, right, you are attaching right some hardware over your right. You can say the operating system related hardware that you have buy, right, or the box that you have buy. So just like ECXI, you have might have heard about. So what it does, right? It gives the capability, right, to interact with the hardware and right segregate those hardware in terms of right placing guest operating system right over it. So that's what hypervisor is capable of. Now, software hypervisor that you generally have used, right? Can anyone tell me any example of software hypervisor? And you people might have definitely have
Yeah.
used it.
Yeah. VMware.
Yes,
Virtual
VMware,
box.
VirtualBox, these are right example of software-based hypervisor. So what you see, right? What you do, you install right utility in your operating system, right? Like this VirtualBox, which is capable of right sharing right operating system resource, or you can say hardware resource to a right operating system that you create, right? So you do what? You download an image, right, and then right execute that image bring up a guest operating system, and you can configure, right, what amount of hard right disk, RAM, and CPU you can allocate to the operating system, right, within the main operating system. True. So this is also right OS virtualization. So obviously we are doing OS virtualization now. Simple example. Obviously using this hypervisor, what I will be capable of, I will, that same hardware in which I had a single operating system, I'm going to have I'm spinning up, right, three different guest operating system, because the machine has that much of resource. So I can, right, bring up, right, multiple, right, you can say virtual instances, right, or operating system over this using the hypervisor. So obviously now each guest operating system now would have their own, right, OS library, obviously because they are operating system, obviously they would have their own OS library. Okay, and now my app A can run in one, right, operating system. My app B can run in another operating system. Now I am running my applications in an isolation, right, or isolated, right, or a dedicated, right, operating system. So obviously it give me benefit of doing anything, right, with my application without impacting, right, other application. Now this, right, results into what, moving, taking you toward what a microservices architecture. If your app B are like a module, right, for a wholesome application that you are building, right, they are interacting with each other. So now everyone have their own namespace, right, as an operating system. They have their own network space, right, and also have their own user space. So in this way, right, you are segregating, and the virtualization is helping you out, and this hypervisor is taking care of, right, basically interacting with the main operating system or the hardware, right, through the hypervisor you are able to interact. Now for example, while I create, right, this virtualization, this is a typical example of, right, in OS virtualization there are two type of virtualization called thick and thin virtualization, and this is a very good example of what thick virtualization. So in thick virtualization, generally what happens, you actually spun up what operating system, right, you create an operating system over it, and that operating system in which you run your workload. Now another thing is what the resources which you are sharing, right, to this operating system are hard shared. Hard shared means once you have shared, for example, some amount of RAM, CPU, right, now it is dedicated to that guest operating system. Now you cannot take it back unless you, right, destroy that operating system, guest operating system. Till that guest operating system exists, right, your resources are with him, so you cannot take it back, right. That is what called hard sharing of resources. So this is a kind of a one of a, right, drawback also. Yes or no?
Yes.
Because maybe that our application A doesn't need that much of resource, and you're giving, right, too much of resource, and you are again, right, doing kind of an underutilization of your resources. uh, Second thing, right, which is a problem, right, in this thick virtualization, what would be it? Can anyone think of? और क्या एक प्रॉब्लम है इसमें?
Communication between different OS, different applications.
That is now not a challenge nowadays, right? Because we have proxies and everything, right, through which we can create all this, right, routings, because everyone have their network namespace, right? Every this operating system would have their own IP, correct? So
Okay.
obviously they will able to communicate. So network level communication is not a challenge.
If kernel gets any
Hmm.
kernel related अगर issue आता है तो वो पूरा उसको impact करता है.
You can say that, but again, it would be with any, right? any solution, right? If you go to thin virtualization, that could be there also. So specific to thick virtualization, the one thing is which, right, basically things in terms of, right, deployment time. Obviously, you will have to launch, right, a virtual right operating system, and the boot time, right, bringing up, right, a full-fledged operating system is higher, right? Yes or no?
Yes, yes.
So obviously boot time, right, is another very important factor, right, which is, right, in thick virtualization, right, taken as a con, if we compared with, right, a thin virtualization. So we now we understand, right, how OS virtualization is helping in terms of what kind of scaling, horizontal scaling. Okay, for example, I have app A, which is taking care of request, right, from users, right, for serving certain web application, and there is a demand, right? There is an increase in demand. So what I will need, I will need to replicate what this OS, correct, with an application A, right, installed in it. So obviously, if I have a resource, right, here in this right hardware, so I can do what? I can create one more guest operating system running, right, app A in it. So in a way, what I am doing? I am doing a horizontal scaling, and in a way, right, I right, I'm making a kind of a uh, using my resources quite well, which is, right, there I don't need a new hardware, right, for launching a new, right, application, because cost of, right, such kind of, right, server are very high. So we want to utilize them properly, so we can use, right, this virtualization for horizontal scaling. A very good example, right, is AWS. And in terms of comparison, right, we have GCP also. So if you see in AWS, when you launch an instance, so what actually you're doing the same thing, what, right, I am explaining. So they're using, right, a thick virtualization. So they have, right, in data centers, right, already, right, right, the capacity of AWS is, right, you can say 6x time than any other vendor or provider, right? That much of, you can say, hardware they already have, right, there in their data center. So obviously they have, right, some, you can say, hardware with good amount of resources in it. And what you do whenever you, like, launch a machine type or instance type with certain amount of CPU, RAM, you just select it, and when you submit, actually you are launching using a hypervisor, right, a virtual instance, right, and virtual operating system. And that is why, right, if you see, there is a time, a boot time which is happening, you have to wait, right, to come into pending state, and then it, right, come into actual running state. But if you work in GCP, you will see, when you start creating, right, similar virtual machine, it is much, much, much faster, right, than what AWS, right, instances launches take time. So reason is what? They are using thin virtualization. They are using what? Actually, you are using containers instead of what? Uh, this kind of, right, operating system or virtual machine. Do you understand what I mean to say, guys? Or any question that you have not understand and you want to clarify or get clarity? I hope it is clear, right? Now, let's compare.
सर
This
एक
is
क्वेश्चन,
please go ahead.
जैसे एडब्ल्यूएस में कोई भी इंस्टेंस लॉन्च करते हैं तो वो उनका पहले से प्री कॉन्फ़िगर्ड स्नैपशॉट है,
Hmm.
तो वो स्नैपशॉट से ही लेता है। लेकिन मेरे को ये क्वेश्चन था कि जीसीपी में कंटेनराइज्ड है तो वहां पर भी स्नैपशॉट होगा या कंटेनर रन होता है
वो
उसमें?
नहीं, वहां पे भी होगा, वहां पे भी आपका जो ऑपरेटिंग सिस्टम का जो सिलेक्शन है वो है, राइट, बिकॉज वो भी जो कंटेनर है वो भी किसी इमेज से ही बनेगा, है ना, बट उसका जो इमेज साइज होगा वो, राइट, काफी कम होगा, ठीक है। और वो एंड्रोमेडा उनका इंजन है, राइट, उसके थ्रू लॉन्च होगा, जैसे अपना डॉकर इंजन होता है, ठीक है। तो अपना उनका एंड्रोमेडा करके प्लेटफॉर्म है। और जो आप स्नैपशॉट बोल रहे हो, वो स्नैपशॉट में ही डिफरेंस होता है। अगर एक फुल फ्लैज ऑपरेटिंग सिस्टम है, उसका इमेज का साइज, और अगर आप कंपेयर करोगे एक, राइट, कंटेनर, जिससे कंटेनर रन हो रहा है जिस इमेज से, उसका साइज, उसमें बहुत फर्क होता है, ठीक है। अगर ये
यस।
एमबीज में है तो वो क्या होगा, वो जीबीज में हो सकता है, राइट। जैसे मैं कंपेयर करूं कि अगर मेरे को यूबुंटू ऑपरेटिंग सिस्टम डालना है, राइट, और मुझे थिक वर्चुअलाइजेशन में डालना है, एंड यू विल गो टू डाउनलोड, इट विल कम अराउंड 1.2 और, राइट, 1.9 जीबी का आपका एक इमेज होगा, राइट, जो आप डाउनलोड करोगे। बट वही Ubuntu का ऑपरेटिंग सिस्टम अगर आप राइट डॉकर से लॉन्च करोगे राइट बेस ऑपरेटिंग सिस्टम, वो हार्डली 24 MB इसका होगा, बिकॉज ऑब्वियसली वो तो बहुत लिमिटेड चीज़ों के साथ आ रहा है। बट आप जो थिक वर्चुअलाइजेशन में कर रहा है तो बहुत सारे जो राइट लाइब्रेरीज हैं उसको भी इंक्लूड कर रहा है, ठीक है। So that is the major difference. Is it clear now?
Yes, yes.
No, the concept is what basically, right? What we understand, basically, it is about isolated environments, correct? Either we talk about thick virtualization or thin virtualization. In some or other way, they are giving you what? An isolated space, right? In which you can run your workload. That is what, right? Everyone is interested, right? Who want to move into microservices architecture. Now, let's see the similar thing, right? How happens, right, in thin virtualization. So in thin virtualization, again, I will copy this. I would have some, right, hardware. Okay, it could be, right, again the same hardware, right, that we have taken as an example, in which I will have my right operating system installed over it, definitely. Right? So I have one operating system.
Deepak, can we say VMware virtualization is a thick virtualization?
Yes, it is. So we told, right, there are hypervisor, right, type A and type B. Type A is hardware based and type B is software based, right? And obviously your virtual box or VMware is doing thick virtualization, in which whatever resources you are sharing, right, for right running your operating system, because you are creating a guest operating system and it is taking the resources which is hard shared, right? And that's the reason, right, it is what a thick virtualization, right? In thin virtualization, soft sharing of resources happen, right? If it is running or running some workload, and if it memory is utilized, it will take from, right, you can say the hardware, and once, right, the workloads are done, right, again it will come back to, right, the main hardware. Okay, got it?
Yeah, Deepak.
Okay, now see, in this hardware again I have a, right, a main operating system, or you can say a base operating system, which is, right, installed. Now instead of hypervisor, right, I am basically, right, using an engine or a container engine, you can say, or not a container, you can say kind of a software, right, which I will install. And if we talk in terms of Docker, generally we call it what, a process called Docker engine, right, which runs. Obviously, Docker engine is what, in terms of it's a kind of a firmware, right, which has a capability, right, to interact with your kernel, or you can say hardware, right? Obviously, through kernel, it will be able to talk with what, your hardware. So that is the capability, right, that this Docker engine, right, have, just like hypervisor. Okay. Now, first of all, when I am talking about thin virtualization and Docker, first of all, you have to understand Docker is a platform, right? If someone says, right, what is Docker? You have to say Docker is a platform. Docker is not a image, or Docker is not a container, first of all. It's a platform which provides a way to have, right, virtualization in your operating system to create isolated environment to run your workload. That is the main purpose, right, of a Docker. So basically, in a way, right, it has democratized, right, thin virtualization. Earlier, right, it was there, right, from 1990s, right. There were, right, operating system like Solaris, right, which comes with, right, inbuilt, you can say, the system, you can say the software through which you can create, right, jail environments, right, using some command like chroot, right, jail commands, through which you can also create, right, this kind of isolated, right, workspace within an operating system. And right, you can use it is for, right, for particular testing, right, within the operating system there is another operating system. So this was there, but right, Docker, right, who built a Docker understood the problem in terms of environments and everything in terms of deployment and come up with a solution. And obviously they written this process which has capability, right, of interacting with your hardware and right, it you can in a way, right, eating up or taking up the resources which is required for a particular workload. Now, in general, right, Docker engine does what? For example, I want, right, operating isolated environment, and in which I want to run my, say, web application or something, right? So, for example, I want something related to an Ubuntu in which, right, I want to have my, right, some web server, right, to be installed. So, obviously, to run that in this operating system, I need, right, what, an image through which I can, right, build basically, right, that isolated environment. Now this image can either be in my operating system, already present in my operating system, right, or either, right, I have to pull it from somewhere. So there is called registry of images, and in case of Docker, we call it Docker Hub registry. So there would be some image registry somewhere, right, over internet or right wherever you have, right, kept, right, in your organization. Right, you can say network or somewhere, right. There is an image repository in which you will store the images, and if I want, right, a particular right, isolated environment or Ubuntu operating system or Red Hat operating system or right, Windows right, operating system or any other operating system, right, those images are present in this image repository. Now this Docker engine also give you a command line utility, right, which you can, right, run. For example, if I run this command, since I have installed Docker engine, I got the command line utility called Docker, right? And if I run, right, the Docker, say run Ubuntu. So I'm running this command in the main operating system, right? Docker run Ubuntu. If I'm running, first of all, right, this Docker, whatever the Docker client is, right, or using the Docker API, will try to talk with, right, the kernel space. Is this Ubuntu image, right, stored here, right? So it will look for the image. So it will basically, right, look into some, right, disk place where, right, this image is present or not. So it will see, right. Obviously if you are doing very first time, obviously you would not have, right, Ubuntu image, right, right, placed, right, in your operating system that you have launched. So if it will not find it, right, locally, then it will go where, it will go to Docker Hub image registry or any image registry that you are using, right. It will talk to that image registry and it will look for that particular Ubuntu, right, image. It will identify, search it, and once it get it, it will do what? It will pull that particular, it will pull, right, that particular Ubuntu image. Once that Ubuntu image has been, right, downloaded or pulled, right, from the image registry, now locally an image is present, right. You have bring down an image. Now let's take as a diagrammatic that this is the image, right, which is, oh my bad, this is the image, and I will write it like a Ubuntu image. Okay, this is Ubuntu image, and as per definition, to create a container, we have to run what? An image. If an image is executed, right, it result into what? A container. So obviously, I am running read my command, right, run that Ubuntu. Obviously, I am executing, right, my container. So if I run this particular, let it be control set, and I will take this. If I run this image, right, I get a container. So this is my container, and in this container, right, I can, right, install what? My web server, and use that web server, right, for the end user. So obviously I'm first running this image, getting a container, I can go inside this isolated environment like this application A, I can put an application A. Similarly, I can again, right, create another container using an image and, right, run app B there, right? And I can also right, run some database image, use some image, right, which contain database, and I create. So I can also create this all, right, isolated, right, components using what? Docker. And in that way, right, in my operating system, I will get, right, this container. So obviously the launch time, or right, the boot time of container is very fast compared to those, right, operating system that we have, right, guest operating system that we have installed in thick virtualization. So it is in very, right, you can say microseconds, right, it will get launched. But in case of, obviously, there would be, right, maybe 3 to 4 minutes of, right, launch time while launching a guest operating system. So this is how, right, basically you are dealing with what? Thin virtualization, in which using, right, you can say, so image, you are launching a container, and in container, right, you can, right, go inside that container, you can, right, deploy those container, you can bake those, right, images with already instructed thing, right, that this or this thing should be run when I will launch my image. So obviously all these facilities, right, are there programmatically, you can achieve. uh, Another thing, you have to think, like, for example, I launch this container. Now container is very raw, right? And after that, what I did, I started baking it, or I started, right, making changes to this container. Okay. So for example, I change this container, and in this container, I put my all application related stuff. So, right, my say app A, I deployed, say, app A inside it. After making in the same container, after changing it, I created app A container. Now I verified as a developer. I did all this development, right? Put all my code, right, related to app A, and it started, right, working. I tested it, everything, right, work fine. So what he will do, right, now he will save this container and convert this container into an image. Now, once I commit this container, okay, so I commit this container. Set. Once I commit this app container, now I am creating what? A new image, right? So it is a app image. So from Ubuntu image, launch a container, made changes to that container, installed application A, and after this application A container, which I, right, made after modification in this container running, right, image, right, this app A, I committed and created an image out of it. Now I have an app image, right, which is, right, contain an operating system Ubuntu, over which my applications, right, are deployed and everything is there. So now I did my development work. Now it is present locally, right, in my operating system. So once I am done with my development work, I can do what? I can push this app image to, right, this, right, image repository. Now same time, tester wants to, right, validate it. I did my development work, right, and our tester, right, wants to test it. So what he will do, right, he would be working on an app, any laptop or any, right, operating system, wherever he is working, his work machine. He needs to do what? He needs to install Docker in his, right, system. Once, if it is a Docker, right, installed in this system, he will do what? He will pull this app image, right, from the image registry. And since it's a platform agnostic, your Docker, so it doesn't care about, because it is running what? Its own image. So your application already running on, right, some operating system which was decided. Obviously you will get that operating system and you will run that. You will get a container, you will get your application also. You can run your test shoots over this application. If you find, right, that image is good, you can say, right, tag it that is tested, and, right, send back to image registry. And same, right, image can be deployed into what? Production. So obviously you can see, right, it is resolving a lot of deployment related challenges related to environment. For example, Developer created application in a operating system, and tester is right testing that right application in some other operating system, which will need certain changes because of the environment are different. So mappings are different, right? Configurations are different. So obviously a lot of बैक एंड फोर्थ काइंड ऑफ कम्युनिकेशन हैपेंस. मेरे एनवायरनमेंट में नहीं चल रहा है, तुम्हारे एनवायरनमेंट में चल रहा है, ऐसा क्यों है, एप्लीकेशन को तो चलना चाहिए. इस तरह के जो कम्युनिकेशन है वो क्या हो जाते हैं, स्टॉप हो जाते हैं. बिकॉज एट द एंड यू आर शिपिंग राइट free right build environment configuration, everything packaged right as an image, and that is what a tester would be using it, right? You got my point. What actually the problem is getting solved in terms of right deploying applications when we use thin virtualization.
जस्ट सर जैसा आप उसको सेव करते हैं जब भी हम डॉकर, तो वो मतलब .img जो भी जिस फॉर्म में से वो बैकअप उसका क्रिएट मतलब किस फॉर्म में होता है, .image में या .tar में?
that is basically Docker's part, right, to handle it. May be creating an ISO kind of image or whatever, right? But it is a Docker way of representing. So for example, if you use Docker commit, whatever the container name that you are working on, right, it create an image itself, right? It give a name to that image. So you just give a name, right? That is my image name, right? And it will store in that way. It will take care of all those, right, abstraction. You don't need to give any extension or anything.
और सर ये जो कंटेनर है इसके बाद मतलब इसमें इज देयर एनी पॉलिसी so that container can restart by itself?
Restart by itself?
हाँ, मतलब अगर मुझे ऐसी कोई पॉलिसी सेट करना है कि वो इस रीस्टार्ट हो
हाँ, तो see, it is basically what it is controlled by, right, Docker client. So whenever you will write run a Docker client command, right, to stop and restart it, you can do that. That is command, right? Docker restart. Okay, so you can cron it, na?
Yes. Without cron, there is no policy, right?
There is no policy, obviously, right? It is certain entity, right? It's a process. Container is what? A process. A process which is in a running state. You need to do what? You need to either stop it or restart it through certain commands, right? When you say right self-healing, if you're in a notion of self-healing, right, that is a different thing. Okay. For example, I want right if there is a bad, it is in a bad health, and I want to right recreate it, right? That is a different thing. So that self-healing capabilities are taken care by what? Container management platform. Okay, so you will write certain platform which will place those policies, right? I need an application of right this container say 3, right? That it should have right 3 instances running at the same time, and if one of the instances is in a bad health, what will the platform will check? Okay, there is one container which is in a bad health. I will write restart it. Got my point now?
Yes. Sir, there was one question also because ये पूछा था कि मतलब मैंने तो डॉकर इमेज और एक डॉकर लेयर भी होता है, तो
डॉकर इमेज और
डॉकर लेयर,
हाँ डॉकर
इमेज,
लेयर,
तो वो मुझे समझ में नहीं आता था, पूछा था कि डॉकर लेयर में
ऑब्वियसली राइट जो डॉकर लेयर की बात कर रहे हो वो डॉकर इंजन की बात कर रहे हो, ठीक है? दैट इज योर डॉकर लेयर. Okay, so your basically the entities are nothing but what? Docker engine, right? Your image, your container. Now if they are talking about overlay network, that is different thing. So there is something called overlay network. So overlay network is generally used, right, if you want to right have a communication between right containers, right, running in different right operating systems. That is overlay. And when you say layers, so layers is what? Over this layer, right, Docker engine layer, we have an image and we have right this container. You got my point?
Yes.
So without that layer, right, where it will right keep Docker engine will keep this information, right? So basically, if you install Docker, there is a path called where live Docker, in which right this all information related to images, right, containers, which right processes that it is creating will right get placed. Okay. Any more caution, guys?
Yes, Deepak,
Bolo?
suppose we have suppose we have assigned any resources like RAM and something memory. So So later we can modify it because that was the problem with previously virtualization
Yeah,
construct.
I got your question. So obviously, for example, if I have this container, right, and in this my application is running, say, okay, application A is running, and this application A is say consuming 2 CPU cycles and say 4 GB of RAM, correct? Say example, right? It is consuming. So obviously, it is taking from the main hardware. Now, say I stop this container. So what will happen? Those 4 GB RAM and CPU cycles are free. Now they are back to what? The main hardware. You have not hard shared it. So when you need, you use from the hardware. In that way, that flexibility is there.
Okay.
But Deepak, here our Docker container uses operating system resources, right?
Obviously,
Because
every
it is on operating system, right?
yeah, that's what, right? It would have to
Yeah,
through
and
operating system. You have installed a Docker engine, and through Docker engine is able to interact with the kernel and the hardware.
yeah, and it is just for clear understanding, Deepak, कि
Mm.
अभी ऐसे हमने बोला कि first of all when we execute Docker run Ubuntu command, so it will first of all search that image into local machine, and if that not found in the local, then it will pull that image from the Docker hub. Okay,
Mhm.
and
Correct.
after that when it run, so after, when the developer run that image, so at that time it will become a container, and he can start his work in that container, and after saving that container, he can create image and share that image to another person who will work on that image now, right?
Not another person, he will share the image at a common repository, of image repository like
Okay.
Docker Hub or anything, right? And from that local place, anyone who want to use that
पानी
image
लेके आया ना?
can use it.
इसी
So
पे रख इसी पे रख
it is a general practice, or process through which we generally work in organization. For
धन्यवाद
example, if you use Docker in AWS, right, for example, and there is something called ECR, right, Elastic Container Registry. So whatever image that you create, you can store it in ECR, and through ECR you can pull in use in your application or whatever application that you want to run. So similarly, Docker has their own registry, and you can integrate your Docker Hub with Git, and through Git also you can pull your image. So these are all kind of a repository, where you keep your images that you have created or your organization images. Okay.
Yeah.
And any more questions? If not, we can do the installation, and in this first session we will understand two things. First, we have to understand the basic command line utilities, how to get inside container, what we talking about various command options with Docker, which we need to understand, how to basically look or detail about a container or a particular image that you are using, how to deal with them. So we will do that, and after that we will go into the Docker networking understanding, and we will do an ingress, Docker ingress lab also. Okay, so let's jump into, yeah,
जेनकिंस को भी हम डॉकर में रन कर सकते हैं, राइट?
there are already created images, right? So you have to go to dockerhub.com. See, ऐसे करो, Docker Hub. This is what I told you, right? Their Docker have their own registry. hub.docker.com generally. Okay, hub.docker.com. Slow, yeah. Here, if you search, this is the search path, and say Jenkins image you're looking for, So obviously, if you use this Docker pull Jenkins or Docker run Jenkins, so it will give you you can say process or a container which has already Jenkins installed inside it. Okay. Okay. Now Let me log in into my AWS account, and we will choose one new machine, right? In which we will be
One
installing.
question.
Yeah, please go ahead.
Yeah, Deepak, as you said, like once the developer pushes the code into image repository, Docker
Mm.
repository, so it's a global platform. So I mean, in real world, it's not possible to export the code publicly. So, mm,
I
so
say
that will be the big challenge.
I didn't say it specifically, right, globally, right? So it's an
Okay,
organization, right, which for example, if you use Docker Hub, so you can use, right, Docker Hub Enterprise, right, which
okay,
have its own, right, policies, right, related to organization, right, users only can access. If you don't want that, right, again, right, you can use, right, integrate with your GitHub, right, Docker Hub, and whatever, right, allowed, right, thing can be, right, be downloaded only, right? That's what the thing is. Okay, so it can be, right, it can be reduced to organization, right, workspace also.
okay,
Okay, and the very good example is, right, ECR, right, I told you, right? So in AWS, you would have your on network, your own services, right? So ECR is your own service, right? If you're using that for you, right, what you have taken. So obviously it is secured, right, enough, right? So your ECR image, ECR images are visible only to you, right, and accessible to you only, right? No, no one else can, right, use it. Okay.
yes, yes, okay,
Perfect. Okay. So I don't have any running instances. I would have one stopped instances, but I will not use that. It was our Ansible Terraform one. So I will do what? I will launch an instance. And see, again, it is, right, platform agnostic. I said you, right. We can do installation in, right, any of the operating system, right. So I will prefer Ubuntu because Ubuntu do not have that much issues, right, in terms of AWS resources. So I will select this Ubuntu. I will just review and launch. Launch. Will use my DevOps learning key. Launch the instances. And for installation, I told you, I think in the one of the lab, right, that we did in Jenkins. So go to Docker IO, right? Install Ubuntu. This you can directly search or whatever platform that you want, right? There will be, right, installation instructions for that. So installation instruction are very straightforward, right? Get update, this packages, then this curl command, right? To get the key, GPG key, and then, right, update and then install Docker C. So this all, right, 5 set of commands we have to run and our Docker engine will come up. Okay. So, so my instance has been launched. Let me name it Docker. I'll copy the IP. We'll try to log in. Here's my end key. Yes. I'm just first updating. then running this apt-get install. Done. I will install the different packages. Done. Copy this curl command. Done. And then update and install. So I'm installing now only Docker C, right? Everything else, right, which is written like CLI and container ID will be taken care of. So it says what? The package Docker C is not available but is referred by another package. Update नहीं किया ना मैंने? नहीं update किया. So there's no installation candidate. Why? We did everything. कुछ रह गया कि हाँ ये वाला command रह गया. This is the command, right, which we didn't run and therefore it is not able to identify the repo. So let's paste it. Done. Okay, now run Docker. Now it is able to identify it. क्या बोल रहा है? This means the package is missing or obsoleted. क्योंकि क्या गलती की है? Echo dev download. Writing next command. T Docker list. Control C cat sudo vi. Oh, what I did. तो गड़बड़ कर दिया, ये बाहर क्यों नहीं आ रहा है? Control Z. Start jobs. Let me do one thing. Kill sudo kill. And share my screen. This rainy season, right? Lot of, so I was right. I actually run some command, right? I want to get rid, right, of that command. So this is the process ID 2044 that I am right trying to kill. So sudo kill -9 2044 jobs. Still right in yeah, there is one more 2040. So I will kill that also. Okay, that also is killed now. And if I grab PI now, it's clean, right? Okay. So what I was actually doing is I have to go to that command, right? etc apt list. That is what I need to copy, and that was where I want to check key entry.
Your voice is very low.
It's breaking.
It
Hello.
was low. Better now.
I think it's because of network, maybe, right? It's very bad. Let me go here. Vi paste it. etc home and then do sudo. Oh wow, what is this? It is a directory. What I'm doing? This is a file, but this file contains very corrupt thing inside it, right? Corrupt data inside it. So what I will do, let me check something wrong with this command. So it is actually putting what this entry, right? Tab entry. This entry should go to in this, and somehow, right, it has not went there. So I will copy it again. I will remove this Docker list file. Somehow, right, something bad happened to this file. Go rm. Right now, I would not have this file anymore. Okay. Now I will copy that command, paste. Now it is echo next line, right? This entry, then $lsp release minus cs table, and then type sudo dev null. This is what I did. Now I will check this. Now it's 130, right? And now I can do a sudo vi also. Now this is the correct entry which came, right? Now I think things would be good. So I just want to identify or postmortem what I did wrong. So I did curl, then here, right, I did the update. That's also fine. And then I realized that I have to run this command, and then I run this command echo slash, and I think I copied the right command and executed well also. But when I did this again, I got an error. Then I try to sudo vi, and this is what I did wrong. That is different thing, right? But before this, there is some problem, right, with this file. Now let me check. The entry is correct. Now I will do sudo apt update. Guys, I'm audible, right? Hello.
Yes.
Yes.
Okay, now that is installed. Docker C. Yeah, it's work now. Okay. Now it will install that Docker CLI and right everything. So once it is installed, how to check whether Docker is installed or not?
Check the Docker version.
First of all, right, you have to check, right, the process, right? Obviously, right, you can simply do ps aux by grep, right? Docker the daemon should be running, right? And you can see, right, a Docker D process, right, which is there. And remember, it is running as what? Root. That you have to understand. Now, thing is, if I do sudo docker ps minus a or docker images, it is working, right? And if I only do with Ubuntu user without using sudo, it is giving me permission denied. So what is the answer for this? If you recall
We
your
need to add
Jenkins
this.
lab.
We need to add the Ubuntu user and that vi sudo.
No, sudo user mode किस ग्रुप में डालना है अपने को? डॉकर के ग्रुप में किसको इंक्लूड करना है? Ubuntu user को, है ना? So this is the command, right? User mode minus az docker, and then docker is the group in which you want to add which user? Your current user. So this variable, right, environment variable $user contains Ubuntu, right? So you can either write directly Ubuntu or you can use, right, your environment, right, variable $user. Now it is, right, executed, but still if I do, right, it will not work. So जब ये command run करते हो उसके बाद क्या करना है आपको? एक बार exit करना है, बाहर जाना है, right, and वापस से फिर से login करना है. ठीक है, एग्जिट करना है और फिर वापस से लॉगिन करना है. Right? Now I am logged in, and if I do now docker ps minus a or whatever docker command, it will work. Got it, guys? ये यूजर मोड क्यों किया पता चला? क्या रीजन है? डॉकर डेमन एज अ रूट रन हो रहा है, ठीक है, एंड root has been part of the docker group basically, right, and therefore it is able to run docker, right, commands. But as a normal user to run, you have to be part of a docker group. Your user should be, right, part of a docker group. then you get the required permission, right, to access, right, Docker engine, right, specs. Now, we will start with, right, basic understanding. First, very basic understanding what I explained you, right. First, if you run this command Docker images, do you see any image currently in my operating system? There is nothing, no output, right, in Docker images. There is no
Yes.
image details. Okay. Now let's run that command Docker run Ubuntu. That is what we, right, did, right. And Ubuntu is an image, right, which is basically present in our Docker Hub registry. So if you here go, see this is, right, the image. If you go and see this image, this tag, it is around, right, 43 MB, right, compressed size image basically, right, this. So there are different tags to it, and generally when we don't use any tag, we will get the latest, and it is around 27 MB compressed size image. Okay. Now, if I Docker run Ubuntu, as per our, right, understanding, first it will look locally, and if it doesn't get locally, it will go to Docker Hub and, right, try to pull this particular, right, image. So see, it's, right, basically unable to find image, right, locally, and then, right, it is pulling from library Ubuntu, right, and then the pull is completed. And if we do Docker images now, what you see, that the size of this image is how much? 72, and the compressed size was what? 22 or 27 MB, right, which we have downloaded. So you can understand, right, basically from, right, this, right, the same thing that I instructed. You got the point, guys? Hello.
Yes, yes.
Yes.
Now, when actually I have said one more thing, right? If I run an image, what happens? Image is executed, and if image is executed, what should happen?
Container.
Container
Container
should,
created.
right, also be created. Now, but that container has been executed, and, right, also did something maybe, right, and after that it will fall into what state? In the exited state. So if I do Docker PS, so Docker PS only says what? The containers which are in, right, running or up state. So if I do Docker PS, I don't see anything. But if I do Docker PS minus A, then I see, right, there is a container, right, which was launched a minute ago, right, and currently it is in what? Exited state.
That is
उसने जो भी उसके वर्कलोड थे उसको एग्जीक्यूट करना था किया और, राइट, आ गया. बट हमने कुछ वर्कलोड तो दिया नहीं उसको, राइट. ऑब्वियसली वो लॉन्च हुआ और अपने आप ही, राइट, एग्जिटेड स्टेट में चला गया. करेक्ट. तो ये एक प्रॉब्लम है कि भाई ये एग्जिटेड स्टेट में पड़ा रहेगा जबकि मेरे को यूज ही नहीं करना. तो इसके लिए, राइट, देयर आर सर्टेन वे, सर्टेन कमांड्स टू, राइट, गेट रिड ऑफ, राइट. So now I'm going to run certain commands, and we will go inside container also, and we will understand some flag also. So to take right example, I had some document also through which, right, you can understand well also. So let me open that. It is in my learning. Okay. So open the lab one. So basically, I will come to that document right later. But now, if I do Docker run Ubuntu and then write bin echo high ethans. So what you understand from this command? What will happen?
it will run the container and echo this and exit.
So you mean to say, right, this echo command that I have written bin echo, right, is actually getting executed inside container, right? Not in this operating system, my AWS operating
Yeah,
system, right?
yeah,
And
it should be. Yeah,
and if I am doing run Ubuntu, obviously I already have an image locally, so it will not pull it again, right? So it will use the image which is already there, and it will launch another container. It will not reuse the container which is in exited state. It will, every time you run an image, it will create what? A new container, new instance of container. Okay, so let's run. So you see, right, I get high ethane in output. Okay, and where from I get it is if I do docker ps minus a, you can see another container has been launched, right, with this container id. And you can see right inside this, what command has been executed? This. After executing this, it
Echo.
went into what? Exited state. Got it?
Yes.
Okay. Now, if I run this command, docker. Okay, let me do one thing. Let me clean everything first, right? So we will learn, right? So that this command, that command will help you understand one more thing. Therefore, I need to clean up. So first of all, how to do a cleanup? For example, I want to clean up my containers, whatever in exited state.
Docker RM.
RM for containers and RMI for images. Okay. So
Images.
Docker RM and then what? Container ID. Correct. This would be the command, right? Docker RM and what? Container ID or container name. Right, this would be the command. Now, if I want to remove right bulk of containers, एक साथ मतलब ये दोनों कंटेनर को मुझे उड़ाना है, तो there is a command called docker ps minus qa. What it does? It lists down all the container IDs, right? And if I pass this docker ps minus qa output to docker rm, obviously, right, it will delete in the bulk or remove it in the bulk. So I'm going to use what? Docker rm in say my Unix scales. That is like a command argument, or you can say command substitution, right? And inside that I can execute my command. So it is docker ps minus qa. So what will happen? It will get one by one both this, right, IDs, container IDs, and it will remove. Now if I do docker ps minus a, I don't see any container. If I do docker ps, obviously I do not have any up container. So I'm clean, right, in terms of containers. And if I want to remove image, obviously docker images, अगर minus qa किया तो मुझे क्या मिलेगा? Image ID, and obviously I will use docker rmi, either image ID or image name, right? Or using this command substitution if I want to clean up everything, right? So docker images minus qa, and it is right untagging and deleting, right? So now if I do docker images, I don't have anything locally now. Perfect. So you know, right, how to clean up now. Now I'm running this command docker run minus I minus t test rm. It is, I think, dash rm. Maybe I'm wrong, but dash rm what I remember. Okay, and say ubuntu and bin bash. So what is basically this command would be doing? Anyone? So obviously I'm going to run which image? Ubuntu image, right? And I will get a container. Minus I is what? Interactive. I need an interactive terminal, right? Basically minus I and t. So I, where I can interact, and I need a terminal to interact. So minus I and minus t flag is there, that for that purpose. And dash rm flag is for what? Dash rm flag is for that once I'm done with my all right activity in container, I want to clean up. I don't want to keep my container in exited state. You got what I mean to say, guys? Or not? यस और नो, -i -t डैश rm का आया. तो अगर क्लियर नहीं है तो लेट मी शो यू दिस कमांड हियर where I have used that rm, yeah, dash rm, right, not this one, right? यही कमांड मैंने लिखा है, राइट. और मैंने यहाँ पे rm flag का मीनिंग क्या लिखा है, फ्लैग टू ऑटोमेटिकली रिमूव द कंटेनर व्हेन द प्रोसेस एग्जिट्स. मतलब क्या होता है, अभी दोनों टाइम हमने जब रन किया पुराने टाइम पे डॉकर रन ubuntu, तो क्या हुआ, एक एग्जिटेड स्टेट इमेज पड़ा हुआ था. उसका मुझे फायदा नहीं, मेरा काम हो गया, राइट. मैंने इको कर दिया, हाई थैंक्स बोल दिया, उसके बाद भी मुझे कंटेनर, राइट, एग्जिट स्टेट में नहीं चाहिए. तो इन सच केसेस आई विल यूज विच फ्लैग, डैश rm flag. And -i -t flag is to get inside the container, right? So let me correct this command here, dash rm, and let me execute. So obviously पहले उसको इमेज मिला नहीं लोकली, उसने पुल किया, है ना. और उसके बाद देखो मेरे को एक अलग तरह का टर्मिनल मिला. एक टर्मिनल किसका है,
Docker
I am
terminal,
inside a right
container.
container, right. Basically an image is executed. Now let me control alt t and log in into, right, another, so I can show you the process so that you understand what I mean to say.
वो एग्जिट स्टेट में क्यों जाता है, मतलब जो प्रीवियसली रन कर रहे थे उसमें आरएम.
सो इसलिए जाता है क्योंकि आपने इंस्ट्रक्ट नहीं किया उसको हटाने के लिए, तो आप उसको, वो सोचता है कि आप इस कंटेनर को रीयूज करोगे, तो आप उस कंटेनर को वापस से रन कर सकते हो, मतलब डॉकर स्टार्ट करके. दैट इज हाउ, राइट, इट इज बिल्ट. यू अंडरस्टैंड व्हाट आई मीन टू से. अगर आपने कोई इमेज बनाया है, राइट, तो इमेज जनरली क्या होगा, कुछ एप्लीकेशन होगा ना उसके अंदर, यस और नो, राइट.
यस.
तो मान लो मैंने उसको लॉन्च किया, लॉन्च करके मेरा काम हो गया, बट वो कंटेनर अगर पड़ा हुआ है तो मुझे क्या प्रॉब्लम है, वो कंटेनर में वापस से क्या कर सकता हूँ, रन कर सकता हूँ ना, डॉकर स्टार्ट करके कंटेनर को ही. तो अभी स्टार्ट करूंगा तो मेरा काम वापस से होगा. तो इस रीजन से मैं हो सकता है एग्जिट स्टेट में रखना चाहूँ. But for certain purpose, maybe, right, there is that is not required, right, then I will use this option, right, dash rm option to clean them up also. Okay, रन टाइम उसको क्लीन भी कर सकते. तो अभी मैं लॉगिन कर रहा हूँ, अभी लॉगिन किया है यहाँ पे, राइट, नए कंसोल पे, उसी ऑपरेटिंग सिस्टम पे. और यहाँ पे अगर डॉकर ps-a किया, so you can see, right, there is an ubuntu image, right, with this container id a553, right, up state में है ना. ठीक है, अप स्टेट में क्यों है, क्योंकि अभी मैं उस कंटेनर के अंदर हूँ, है ना. इफ यू सी राइट हियर, इसको मैं थोड़ा इधर कर देता हूँ. तो अगर आप ये देखोगे तो मैं यहाँ पे इस कंटेनर में हूँ, इसलिए अप स्टेट पे है, राइट. यहाँ पे मैं ls करके देख सकता हूँ, तो इसका अपना खुद का फाइल हायरार्की है, राइट. इसके अंदर मैं कुछ भी इंस्टॉल करता हूँ, काम कर सकता हूँ, करेक्ट. लेकिन जैसे ही मैं इस कंटेनर से एग्जिट करता हूँ, अभी यहाँ पे एग्जिट करता हूँ, ठीक है, आप देखोगे तो ये कंटेनर आईडी ये वाला और यहाँ पे देखोगे सेम है, राइट. बिल्कुल. अभी मैं यहाँ पे डॉकर ps-a करता हूँ, गया वो कंटेनर नहीं रहा ना, तो किसके कारण हुआ, डैश rm के. तो ये ऑप्शन से क्या, ये एग्जीक्यूट किया, काम खत्म, मेरे को कंटेनर ऐसे प्रोसेस, राइट, इन कहते हैं एग्जिट स्टेट नहीं रखना है, मेरे को क्लीन करके रखना है, तो मैं आई विल यूज दैट ऑप्शन. एवरीवन क्लियर?
Yes.
Okay, now let's come to write a command in which we want to run that, we want to say that my container should be in running state, मतलब as a background वो run होते रहना चाहिए, ठीक है, up state में ही रहना चाहिए, exit state में नहीं रहना चाहिए, up state पे ही रहे. And whenever I want to get inside that right container, I would go, right, as a process वो running as a running process पड़ा रहे, है ना. तो उसके लिए flag है -d. Okay, so I will copy this command and explain this command.
दीपक, हाइफन आरएम के साथ में आईटी देना ही पड़ेगा ना, मतलब
अगर आपको उसके अंदर जाना है, किसके अंदर, कंटेनर के अंदर जाना है, तो अगर नहीं दोगे इट्स फाइन।
नहीं देंगे तो फिर वो जो भी कंटेनर बना करके फिर वो डिलीट भी कर देगा,
हाँ
एग्जिट भी हो
बिल्कुल,
जाएगा।
जैसे जो पहला एग्जांपल था जिसमें हमने हाई इथेंस लिखा था, राइट? तो मैं उसमें डॉकर रन डैश rm लिख के करता, तो ऑब्वियसली वो हाई इथेंस करने के बाद उसको हटा भी देता। ठीक है,
ओके, गॉट इट।
मीन्स आई लगाए तो इंसर्ट भी हो जाएगा।
माइनस
आरएम आई यूज किया, आई मींस इंसर्ट भी करके देगा मतलब
नहीं 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 नहीं, ऐसा कुछ नहीं है। dash rm is there, I is interactive, I is what for interaction, I need what an interactive terminal, मैं उसके साथ बात करना चाहता हूँ, राइट, उस कंटेनर के साथ। तो माइनस आई फ्लैग is what it is written here. Flag allows you to make an interactive connection by grabbing the standard input. आप कैसे इंटरेक्ट करोगे, किस चीज से बात करोगे, वो इंटरेक्शन के लिए आपको दो चीज चाहिए, एक टर्मिनल चाहिए और टर्मिनल के थ्रू यू कैन इंटरेक्ट बेसिकली। जो अभी मैं
अगर
यूबुंटू
अकेला
पे
आई,
भी, यस,
सॉरी, अगर अकेला आई यूज करेंगे तब शायद
नहीं होगा, उससे नहीं।
एक अभी आपने सर
होगा
ऑप्शन
ना,
आरएमआई
TTY।
लिखी।
RMI is for image deletion, Docker RMI,
यस,
that is for what, deleting image. Okay, okay, now let me move ahead and run this, paste this command, and I just want to explain this command. Now if you see this command, can anyone tell me what is the image name और कहाँ पे image name? Ubuntu is the
Ubuntu,
image name.
हाँ,
And then
Ubuntu
what is then dash name daemon?
कंटेनर नेम,
सर्विस कंटेनर।
It is a container name, right? If you don't give dash name option, Docker takes some random, right, name and give to it, right? If I want, no, I want to give a specific name, then you have to use what, dash name to give, right, your container name. Got it, this part? Okay. Minus D is running your image, right, in a background mode, so your container would be running in up state. Okay, so minus D does that magic. Now bin sh is nothing but I'm running a script inside my container, right, using minus C option, in which I'm running a while loop, which is an infinite loop, and it is printing, right, echo or hello world, right, every 1 second. So but I will increase it to 10 seconds, else it will overwhelm, right, my operating system. So every 10 second, right, it is going to print echo hello world inside container. So मैं उसके अंदर एक वर्कलोड भी रन कर रहा हूँ, एक प्रोसेस, राइट, मेरे कंटेनर के अंदर में एक शेल कमांड कंटिन्यूअसली, राइट, रन हो रहा है, राइट, एक लूप में रन हो रहा है, और वो मेरे किस कंटेनर में रन हो रहा है, मेरे कंटेनर का नाम है डेमन, जो कि यूबुंटू इमेज से लॉन्च होगा, राइट, जो मैं रन करूंगा। इज दिस कमांड क्लियर? माइनस डी ऑप्शन का मीनिंग क्लियर हुआ? माइनस डी मतलब क्या है, बैकग्राउंड मोड पे उसको अप स्टेट पे रखना, ठीक है, कंटेनर को। मैंने एंटर किया, तो यू कैन सी, राइट, आई गेट अ कंटेनर आईडी, ये क्या है, मेरा कंटेनर आईडी है। अभी मैं डॉकर ps-a करता हूँ, तो मेरे को दिख रहा है, राइट, ये कंटेनर लॉन्च हुआ है, और इस कंटेनर पे, राइट, बेसिकली ये कमांड रन हो रहा है, और ये अप स्टेट में है ना, अप स्टेट। अभी मैं इस कंटेनर के अंदर जा सकता हूँ, कैसे? इसके लिए कमांड है डॉकर, ऑब्वियसली जब भी हमें कंटेनर के अंदर जाना है तो क्या होता है, माइनस आई, है ना, इंटरेक्टिव, माइनस टी, टर्मिनल चाहिए, एंड देयर इज एन ऑप्शन कॉल्ड exec. Okay, so you should use docker exec first and then minus it. Okay, and the container name or what, container id. तो अभी हमारा कंटेनर नेम क्या है, डेमन, और हम कंटेनर आईडी भी डाल सकते हैं। और आपको कौन सा शेल चाहिए, वो आई नीड अ bin bash shell चाहिए। now you can see, right, I'm inside what, container, right? Inside this container, right, I can see, right, there is certain file, ps utility might not be installed, but let's see if ps is there. Yeah, ps is there, and right, it is saying, right, basically bash and all that. This is another terminal, right, bash terminal, in which I am. So basically if you see, it is running a workload, right, while loop which is there, and how we are certain that कि वो वहाँ पे वो run कर रहा है, I'm coming out of it, मैं exit करूंगा, इसका ये मतलब होगा क्या, क्या कंटेनर बंद हो जाएगा? अगर मैंने एग्जिट किया तो कंटेनर बंद हो जाएगा क्या?
यहाँ पर टर्मिनल एग्जिट होगा सिर्फ।
हाँ, सिर्फ टर्मिनल एग्जिट होगा। बंद इसलिए नहीं होगा क्योंकि मैंने -d ऑप्शन किया है कि उसको बैकग्राउंड मोड पे रन कर रहा हूँ, है ना। अगर rm यूज किया होता तो यस वो बंद हो जाता। अभी मैं अगर docker ps-a करूंगा, ठीक है। अभी एक चीज देखते हैं हम लोग, डॉकर इंस्पेक्ट करके कमांड होता है, डॉकर इंस्पेक्ट एंड द कंटेनर आईडी और कंटेनर नेम। ये क्या बता रहा है आपको, पूरा डिटेल बता रहा है कि आपका कंटेनर का आईपी क्या है, राइट। कंटेनर को देखो आईपी एलोकेट होता है अपना, ठीक है। ये आईपी एड्रेस है उसका, उसका अपना खुद का मैक है, राइट। आइडेंटिटी है, राइट। उसका खुद का अपना नेटवर्क स्पेस है, राइट। नेम स्पेस है, एंड इट इज यूजिंग ब्रिज नेटवर्क बेसिकली। एंड व्हाट वर्कलोड इट इज रनिंग, इट कैन बी आइडेंटिफाई यूजिंग डॉकर इंस्पेक्ट। तो अगर आप देखोगे ऊपर में, तो ये बताएगा कि ये क्या चीजें रन कर रहा है। ये क्या रन कर रहा है, mean as such, and this is the argument, right, which is actually it is in a running state, and you can say the state is what, running, right. So in that way you can identify what workload using docker inspect, what workload, what network namespace, and every detail about your, right, basically the container that you are running would be there. Okay, now another thing, right, what is running, I can log it also. So there is a command called docker logs -f, right, so which I have noted down here also.
सर एक क्वेश्चन है,
हाँ पूछो पूछो।
सर डॉकर इंस्पेक्ट यूज किया तो इट विल शो ऑल द इंफॉर्मेशन रिगार्डिंग द कंटेनर, राइट। सो अगर उसमें से कुछ स्पेसिफिक इंफॉर्मेशन निकालना है मुझे, सिर्फ
ये
आईपी या,
हाँ निकाल सकते हो ना। ये कैसा स्ट्रक्चर है, अगर इसका आउटपुट देखोगे कैसा है, अगर ऊपर से
JSON।
स्टार्ट करो, बेसिकली एक लिस्ट है, एक इनिशियली एक लिस्ट है, इस लिस्ट के अंदर जेसन है ना। अगर देखोगे एक लिस्ट है
यस,
और लिस्ट के अंदर जेसन है, तो यू हैव टू राइट अ पार्सर, राइट। और इवेंचुअली इफ यू आर गुड इन यूनिक्स यू कैन यूज awk, right,
यस,
sed and all those, right, to from the keywords, right, that you want to fetch. But you can also write a parser for it, right, using python. So you can treat, right, whatever inside it is JSON, and right, ID is a key, created is a key, right, and you get the values. Okay. Okay. Now I'm logging. So you can see, right, this all hello world, right, and everything is getting printed. Okay. So every 10 seconds, right, it is printing hello world. This is my workload, and right, my workload log is also, right, I'm able to see. Now I can stop my container, right, using docker stop. Yeah, I am coming to you. Docker stop daemon. So what happened if I run this docker stop daemon? What will happen? My container will get into, right, stop state. So my workload, which is running, right, this while loop will also get stop, right. Okay, and if I do docker ps-a, you can say, right, it is in exited state now, correct? But I can bring it up again. Yes, Vishal, you had some question. Go ahead.
What command you execute to print that hello world?
Hello world. Okay, means hi thanks, or yeah, this hello world you are asking, this hello world.
No,
So
no,
it is,
you, yeah, docker logs dash uf daemon. Okay.
so basically, right, from the daemon container, I want to write log, right, about my container which it is generating. Okay, so this is what, right, command does. Okay, so
Yeah.
This
it's just like a
-f
console
is for follow.
follow. Yeah.
Yeah.
Okay. Yes.
Okay.
Yes. Correct. That's
Okay.
true.
Oh, okay.
Now, if you see it is an exited state, now I can start it. First, if I run docker logs again, right, that command. So you will see, right, it's not going ahead now, right? The flow logs are not basically uh, uh, shown, right? So it has been stopped. Therefore, whatever it has already, it is displaying that. Now, if I start it again, what happened? It has been started, right? If I do docker ps-a, we can see, right, it is an up state, right? It has come again in up state, and if I do docker logs -f, now it started, right, flowing the logs. Okay. Now, if I come out of it and I want to basically delete or remove that container, right, which I see, right, मुझे उड़ाना है तो मुझे क्या करना पड़ेगा? Docker which command? इसको मेरे को कंटेनर को
RM
रिमूव करना है।
docker RM.
No,
I think you error
you
देना चाहिए
cannot
ना doc
you cannot directly remove a
stop.
running container. तो पहले क्या
Yeah,
करना
we need to
पड़ेगा?
stop and
Stop
stop.
करना पड़ेगा, correct, right? So docker stop daemon. Now it will go to exited state, and after that you can do docker rm daemon. Okay. Now I will do docker rm daemon, and if you see, right, if I do docker ps minus a or docker ps, I don't see any, right? It has been cleaned up. Is it clear, everyone, this part?
Yes.
Okay. Now I will take the network session tomorrow, because there are a lot of things to be, right, discussed, right, in terms of, right, how the networking happens, right, in Docker, and which is very important, or a base session for you. This is nothing but a command line understanding, right? This in Docker inspect, how to start, stop, how to get into, right, container. This will need definitely a practice. So I would suggest you, everyone, right, to repeat this, install Docker, and, right, run this command, play around this command, right? Go inside a container, create certain files, right? Stop it. Also explore like Docker commit command and all that, right? You can explore, though we have labs, right, in which we will be doing that. But I would say, right, some administrative command knowledge, right, you can, right, basically download a cheat sheet and do that. Related to Docker network and everything, that we need to understand few of the internals, like, right, what are operating system net filters, right, which comes in picture in terms of doing port mapping and other stuff, right, that I will, right, first explain you very our whole what ingress in Docker is, and, right, how basically, right, internally it happens, right. So basically where the route table or IP tables comes in picture and every stuff, right, that we'll discuss tomorrow. Okay. Any question before I'm closing the session?
You will be covering load balancing using container as well.
So yes, while doing Kubernetes, there we will have load balancer type and, right, node type and basically hosted type. These are there. Okay.
Okay.
Obviously, see, when I will speak about network, obviously net load balancer will come in picture tomorrow itself in context.
Okay.
So it is internal, right? It is, you don't need to create a load balancer. Okay.
Okay.
Deepak, do we have any command where which means like we have -rm, yeah?
Mm-hmm.
So the same way we can remove the image also once we have done.
Yeah, I told you, right?
No, in a single command. No, means
In a single
while
command,
running the content. Yeah.
all the images, right?
No, means like -rm we use for removing the container once done with the container. So
Mm-hmm.
the same way, once done with the container, removing the container and the image also. So single
So
command for
I
that.
can
Do we have?
automate using Docker RMI, but I don't
Yeah.
know any other option that does that.
Okay.
Okay.
Okay. Means
If it is
yeah.
there, do let me know. But I don't think, right, there is.
Okay.
Okay. So you have to use
Yeah.
Docker RMI.
Yeah. Means, okay. Got it.
Okay. So are we good to close, or any last questions that I can take again? Okay. If not, thank you. Let's meet tomorrow. Let's do tomorrow a bit early, right? Let's meet at 9, because this Docker session and right labs can be done, right, with that period of time. So I would suggest, right, let's meet tomorrow at 9 a.m. Okay. Okay.
Sure.
Yeah. Thank you, everyone.
Okay. Thank you.
Thank you.